Hi, it's Mr. Baker again, and today we're going to be looking at drawing forces. Okay, so we've looked before at how if we've got two parallel forces, we can find the resultant of those. If they're going in the same direction, they would add together, and if they're going in opposite directions, you'd take one away from the other. But today we're going to be looking at examples of a little bit more like this. So we've got forces that aren't acting in the same direction, they're acting at different angles to each other. And then we're going to see how we can find what the resultant force of that would be. So imagine, let's say on this one, you've got an object here and it's being pushed by two different forces, one pushing up like that and one pushing along like that. Now, if you can remember, we've said that the way that we can represent the forces are we use an arrow, and the size of the arrow shows us how big the force is, and then the actual direction that the arrow is going in shows us the direction that the force would be going in. And we would use scale diagrams to draw those different things. So you can see this force here is smaller than this force here. We could have a scale and we could measure the size of this force, and we could say it's a representation of a real force. And we've got some other different examples here of different forces. So let me show you this. Okay, so this is the same thing really that I just showed you. We've got one force up and then one force across. Here we've got scale, so I've drawn it on some sort of graph paper here. And so we've got a scale, so I've just drawn here, and you can see that this one here, we've got 10, it goes up to 15 here. So this size here would be 5, and then here we're going across from 10 up to, what's that, 18. So this one along here would be 8. Okay, so we've got 5 and we've got 8, and so we can describe the forces here. So these are what we'd call the components. So these are the two forces that would make up the resultant force. Okay, and if I show you what this would be if I added those two forces together, then it would be a force that looked like this. Okay, so let me show you another example, one that we've done before. Let's take that away. Okay, so let's look at parallel forces for a second, just to remind you. Let's take the sum off. So if I've got these two forces here, so I've got an object I'm pushing with two forces, the sum of those forces, in this case, look, is that. If I have got two forces in opposite directions, then the resultant is going to be this one. Take away this one, because this one's bigger than this one, and so we've got a resultant which is going towards the left, that's that big. Okay, so you can see what I've just done is I have just taken that, and you can see that that's then just going to be the sum of those two forces. Now I could have it like that, I could do it as drawing like this. What we tend to do is we tend to do something like that. That's one of the ways that we can do it. And so we have this, we call this the tip to tail method, where you'd have a force along the bottom and a force up, and the tip of this force would meet the tail of that force, and that would be our resultant force. In a similar way, I could draw it like this, and you can see that what we've done is we've made a parallelogram. We've got these two lines here which are parallel to each other, we've got these two lines here which are parallel to each other, and then this is our resultant, which is going from the base of those arrows to where those tips of those arrows meet there. And that gives us exactly the same result as before, but we'd call this the parallelogram method. Okay, so imagine that I've got these two forces acting on an object. So I could use the tip to tail method, and I could do that, and draw an arrow from there to there. But the method really that you need to know is this parallelogram method, and for that then you need to draw the parallelogram. So we need to draw this arrow in here, and that's got to be at the same angle. So you'd measure this with a protractor, so you'd measure the angle from there and you would measure the distance of that, and then you would draw that there. So that line there would be exactly the same as that line there, and then the same again. We know that this one's horizontal, so it's not so bad, but then you would measure, or you'd look at the squares, see how long that line is there, and you would draw in the other one there. And so we've got now a parallelogram, and what you do then is you would draw your line from there to there, or your arrow from there to there, and that there would be the resultant. They've called it the sum here, the resultant force. So this, and that's basically what it is, it's the sum of these two. So if I had two forces acting on an object at this point, it would be the sum of those forces would be this one, and it would be this big, and it would be at this angle. So to find out how big it is, I'd use my ruler and I'd measure from there to the tip, and I would find out what that was, which is 29.6 apparently, and then I would find out what the angle from there to there is by using a protractor, and I would just measure that angle there. And so in the exam they might say, what is the magnitude or the size of that force, and so that is what you've just measured there. But obviously you've drawn this as a scale, so whatever you've said that one of these squares represents, let's say one of these squares represents 1 Newton, then however many centimeters then you've measured, you'd have to convert that using your scale, and then you'd have an angle here that you would be able to describe the direction of that force with. Okay, thanks very much. That's the end of this one. See you next time.